So 6.2 is very similar to this stuff. It's just basically trying to make one side equal the other. That's how we prove things, right? So we're trying to make one side equal the other. Now, sometimes it's harder than not, and sometimes it's a little bit easier. When I look at something like this, how can we cross something out? The bottoms aren't the same, but maybe we can come up with a common denominator. Isn't that how we kind of add fractions? Okay, so if we're going to come up with a common denominator, I'm going to multiply this side by cos theta minus 1 on the top and the bottom. Okay, I'm going to have to fix this. Sorry. Every day, hey? Something happened. Okay. Maybe they do it on purpose. And on this side, we'll multiply by secant theta minus 1 on the top and the bottom, right? Because then we can come up with a common denominator. And I don't like writing things over and over and over again. So my common denominator is what? Cos theta minus 1 times secant theta minus 1. That's my common denominator. Now on the top here, I'm going to have to FOIL, right? Cos times secant is going to be cos times secant theta plus cos theta minus secant theta. It will be there. But I'm not going to do two steps at once because we're doing proofs. So that we'll have to multiply it out, and then we'll have to realize, well, cos and secant, we could write secant as 1 over cos and then replace it as 1. And then negative 1 times positive 1 will give us negative 1. That is just this thing FOILed on this side, right? Then there's a plus sign, okay? And then we have to FOIL it again. It's pretty much the exact same thing except for opposite sign. So it's secant times cos. So secant times cos, and then it's negative 1 times cos, so it's negative cos. Positive 1 times secant, so plus secant. And then minus 1 times plus 1, which will give us another minus 1. Sorry, I kind of had to cram it in there. Okay? If we're going to carry on, some of you will notice I have a plus cos and I have a minus cos, so that crosses off, right? I also have a minus secant and a plus secant, right? Now, cos times secant is like saying cos times 1 over cos, right? Minus 1 plus secant, which is 1 over cos, times cos minus 1, all over cosecant theta minus 1 times secant theta minus 1. Now, like Aaron was saying here, cos times 1 over cos, or cos times secant, that's just 1. So now we have 1 minus 1 plus 1 minus 1. What does that equal? 1 minus 1 plus 1 minus 1. 0. And we get 0 over a denominator. 0 over cos theta minus 1 times secant theta minus 1. 0 over anything is 0. It's okay, right? 0 over a constant, it's okay. So that means it's equal to 0, and we kind of proved that the one side is equal to the other side, and the other side was 0, right? It's kind of nasty, but kind of nasty. Okay, this is really nasty. I'll be honest there. If you come up and you've got two fractions, and they don't have any like of those identities. Like the Pythagorean identities are all squared, right? So this has no real identities or anything in it. The big thing is you could have changed secant into 1 over cos, but then it would have got even nastier because it would have been 1 over cos minus 1 divided by 1 over cos plus 1, and it just kind of looks crazy. So if you look at something like this, my key thing would be, let's find a common denominator and then add that crap, okay? So looking at the next question. Next question. Cosecant squared cosecant squared over 1 plus tan squared equals cotangent squared. So what I would do is I pull out my trig identities because I see squared. I look at my Pythagorean identities. Is there something that says 1 plus tan squared? Yeah. Secant squared, right? So I'm going to take this side and I'm going to make this one secant squared. Now this is all fine and dandy. Do we have anything that we know about tan? We have to get cotangent. What's cosecant squared? What is cosecant? 1 over sine, right? So I can write this as 1 over sine squared, can I not? What can I write secant squared as? 1 over cos squared. What happens when you divide by a fraction? Okay, so when I multiply by a reciprocal, it actually is written as what? 1 over sine squared theta is times cos squared theta over 1, right? What does this become? Cos squared theta over sine squared theta. Do we know what cos over sine is? Cotangent, right? Cos over sine is cotangent. And so we will call this cotangent, but because it's cos squared over sine squared, it's cotangent squared theta. QED. Oh, sorry. That's the end of the page though, right? Are you happy with that? Some of them are easier than the others, right? Next page. Cosecant plus tan plus sine equals sequent. This is our last page, right? We have 2 more. So, I don't see any Pythagorean identities. The only thing I can think of is, if there's nothing I can really think of, I switch everything back to cos and sine. Okay? So, in the end, if you look at it and you're like, I have no clue, sine and cos. So, I can write this as cos theta plus, what's tan? Sine over cos. And this is times sine theta. So this gives me cos theta plus sine squared over cos. Does it not? So we could change sine squared into what, like cos squared minus 1 or 1 minus cos squared if we really wanted to. But then I don't know what I would do with that. When I look at this, I have a whole number plus a fraction. What do you think I'm going to do? Oh, I don't want cos squared on the bottom. This said cos theta, right? I'm going to make it into a common denominator. So I'm going to multiply the top and the bottom by cos. Okay? So I probably shouldn't have done that because that's not a good proof. I should have left that as cos theta and then wrote in that I'm going to multiply the top and the bottom by cos. So that gives me cos squared theta over cos theta plus sine squared over cos theta. Right? Is everyone okay with that? So I looked at that thing. It's got a fraction in it. As soon as I see fractions, lots of times I go, okay, common denominators, combine them. Okay? What is actually underneath this? It's over 1. So how can I make it over cos? I multiply the top and the bottom by cos. So then when I look at this, I get cos squared plus sine squared. That's equal to 1. Pythagorean identity. 1 over cos. What is 1 over cos? Secant theta. Is that what we're trying to get? Gotcha. This is my favorite part, is to write QED. You got to write it fast, and you got to write the E like that fancy Greek Latin E. Just because it's funner that way. Last one. Blech. What do you want to do? Okay, cool. I like that idea. Common denominator. So what do we have to do to find a common denominator? Multiply this one by cosecant on the top and the bottom. Multiply this one by cos top and the bottom, right? Shh. Let's do it his way, and then we'll come back. Then we'll come back and do your way. More than one way to skin a cat. Okay, you guys? Now. No. Okay. So, on the bottom, we have cosecant theta times cos theta. And on the top now we have cosecant times sine minus cos squared. Right? Do you guys agree with me there? What is cosecant? That's me trying to write something else. Just cos theta. Cosecant times cos theta. Cosecant is 1 over sine. So if I go 1 over sine times sine minus cos squared all over cosecant theta times cos theta. 1 over sine times sine, that's 1, right? So I get 1 minus cos squared over cosecant theta times cos theta. What's 1 minus cos squared? Sine squared. Yeah. We're finishing this one first, you guys. Quit it. What is cosecant anyway? 1 over sine. Okay? So we get sine squared over 1 over sine times cos. That's cos over sine, right? What do you do when you divide by a fraction? Flip and multiply by. So we get sine squared times sine over cos. And so what do we get? Sine over cos is tan. What are we trying to get anyway? I forgot. Sine squared times tan. That's what we're trying to get, right? This is tan. We're done. Woohoo! I guess I should pay attention to what we're trying to get. Okay. You want to take over? You want to do your way? Okay, Aaron's just going to tell me what to do here because he had a different way of starting, right? And I will tell you guys that it's okay to have different ways of starting, and it should happen that way because sometimes you just go around a little different ways. Okay, what's going on? What were you going to do? He was going to take sine theta and cos and leave that alone and go 1 over sine, right? So then what is he going to do here? Multiply by the reciprocal of that second fraction, right? So I get sine theta cos theta minus cos times sine, right? Then he would probably say, hey, I want a common denominator to combine these. Is that what you're going to say? No, what were you going to do? Oh, so you change this to 10. So then we have 10 times, right? But then where are we going next? Okay. This is good. You could have done that, but we need multiplying. So in order to get multiplying, you need common denominators because you got to get rid of that minus sign. So I would have told you to stop here, come back up here, and multiply by cos over cos to get a common denominator here. Okay? So if you notice that you've got a big subtraction and you need multiplying, you need common denominators. So what does that get us? That gets us sine theta minus cos squared times sine over cos, does it not? Then I would factor a sine out, right? Because if you look here, here's one term and here's another term, right? Here's your next term. So factor out a sine. So if I pull out a sine, I get 1 minus cos squared all over cos. What's 1 minus cos squared? Sine squared, right? So we get sine times sine squared over cos. Now, lots of you can look and see what we were supposed to have. We were supposed to have tan times sine squared. Can you see tan here? Right? So you could separate it so it says sine over cos times sine squared, and then you get tan times sine squared, and you're done. Yeah? Oh, good. Here is a good question, and it happens quite often. She's tired, hey? Hi. Lots of times people think that they can come in here and cross like this. When can you cross like that? When you're multiplying. Are we multiplying? So you cannot do that. That is a no-no. Okay? So, assignment, right? I don't like your textbook, so I'm doing an assignment out of an old guy's textbook that I really like. Bert Thiesen's textbook. I even gave you the answer keys because I thought it's important for you to double check that you're doing things properly. Okay? You get to choose. Yeah, you still do it on loose leaf. On assignment 6.1, there's 46 questions, you guys. 46 questions. Okay, now what am I going to do? Multiples of 4. You can't do multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44. Okay, all those. If you're feeling happy and you're good with them, then that's all you do. If you're still struggling after you complete that and you're having a hard time figuring out what to do more. Okay, but multiple of 4. Okay, any question off of this assignment sheet I could ask. Okay, but multiples of 4. Good luck. It's like rain. Oh, Reese, are you okay? Okay, ready, Cheyenne? Oh, that was not even close. Okay.